Hello, welcome back to our Chapter 6.3 video lecture series in the Lock 5 textbook. And we ended the last video looking at the general confidence interval formula that works for most statistics. Take your sample statistic plus or minus z star times your standard error. If we're dealing with a difference in proportions, the statistic is p hat 1 minus p hat 2. And z star depends on confidence, and we have this messier standard error formula. All right, so let's look at an example. Metal tags and penguins. How detrimental are metal tags to penguins? So a study looked at the 10-year survival rate of penguins tagged with either a metal or electronic tag. Right? So scientists will tag penguins to see their migration patterns, just try to get more information. And you can see this poor little penguin's got a tag on its flipper. All right, and after this 10-year study that was published in 2011, 20% of the 167 metal tag penguins survived, and compared to 36% of the 189 electronic tag penguins survived. Okay, so I'm going to look at this and say, well, it looks like it's better to do electronic tagged penguins. Decent sample sizes, and we have decent change or difference between these two, 16% greater survival rate for the tagged penguins. So let's go through and calculate and compute a confidence interval for difference in proportions. I want to set this up here. All right, I rewrote down the information for example 2 from the slides. All right. Okay, the first thing I want to note is our requirements met to use normal distribution. And we need to check to see, are there at least 10 successes and 10 failures in each group? Well, if we take 20% of 167 is, without my calculator, 0.2 times 167 is 33.4 successes. And we could take then 167 minus 33.4 to get 133 equals 133.6 failures. And success in this case is survival. Failure is that the poor penguin died within 10 years. And we'll call this the metal tag group. And if we look at the other group, we have 36% of 189. And that is about 68.04 successes. And let's take 189 minus 68.04. Or let me do this another way. So there's two different ways to get the number of failures. I could also take 1 minus 0.36 and then multiply that times 189. And that will give me, excuse me here. That should be 189. If you multiply those two together, you're going to get 120.96 failures in the electronic tag group. So the requirements are met to use normal distribution. All right, so we want to make sure we have at least 10 successes, 10 failures. All right, in this formula, let's first get z star. And we're dealing with a 90% confidence interval. That's 1.645. Z star. And don't forget, you could always get that if you go to stat key, click on the normal distribution, And make sure, click on Detail, and then make sure you get 90.90 in the middle. And here's your Z-star, 1.645. All right, so we have this. I'll say P hat. Instead of 1, I'll use metal for the metal tags. That's 0.2. And the second sample proportion, I'll say P hat E for the electronic. That is going to be 0.36. 0.36. So I want to write out then P hat M minus P hat, actually let's do it this way, P hat underscore E minus P hat underscore M. That's going to be 0.36 minus 0.2, which is going to give me 0.16. So this is my statistic. .0 or 0.16. So then we could take the 90% confidence interval is, to write this out, using this formula above, I've got 0.16 plus or minus Z-star 1.645. And now this is going to be messy formula. If I fill this in, P hat 1, electronics 0.36 times 1 minus 0.36. And that's the electronic group, electronic tag group. So that was 189, electronic tag group. And then I'm going to add that to 0.2 times 1 minus 0.2. And the second group is the metal tag group, and there was 167. All right, now we should have this whole thing underneath the square root. That ends up being 1.645. And if you throw this in your calculator, oh, sorry, I had this earlier. Let me go double check. I got this to be about 0.04666. And finally, multiply those together, 0.16 plus or minus, multiply the Z-star times my standard error, and 1.645. I get this to be about 0.076755, etc., etc. So I'm going to write this as an interval. If we take 0.16 and subtract this answer, the margin of error, we get about 0.083. And then if we add that value, 0.16 plus 0.076755, that's about 0.2367. So I'll round to 3 decimal places. So this is constructing the confidence interval using the formula. So we would say we are 90% confident that the electronic tagged penguins survive 8.3% to 23% more than the metal tag.